Ladies and gentlemen, it is Friday. Welcome to the season finale of our epic online quantum technology meetings. Ladies and gentlemen, are you ready for the season finale of our online quantum technology meetings? And what a season it has been. We have addressed the main application fields in which quantum will disrupt our future and seeing them from the end user perspective. Looking back, some highlights come to mind. Remember when we discussed with the space industry about their future dreams on secure space nanosatellite networks and precision gravitometry? And we match those unmet needs with the robust manipulation of single atoms and photons on a chip. Do you recall the day we addressed e-mobility and the need for quantum computing to solve the upcoming challenges in autonomous driving? We discovered that each self-driving car will generate around 40 terabytes of data after 8 hours of driving, and we link that to 5G and synchronization, including quantum key distribution for security. We uncovered many business opportunities. And do you remember when we did quantum for medical? When we had Merck and GE Healthcare represented in the room? What an epic afternoon discussing low-light imaging and the needs for time-gated spectroscopy. Perhaps the best of them all was the one about quantum key distribution itself. We spent 2 hours linking EPIC members with the OpenQKD testbeds funded by the European Commission. This resulted in opportunities for the photonics industry to test their technology in real quantum use cases. But most of you do not know about my favorite meeting, because for obvious reasons, it is not in YouTube. Back on the 26th of February, we discussed with the defense and security sectors about current unresolved issues. Those were GPS-deprived navigation and long-range LIDAR. And we matched this with the need for more accurate lasers, as well as efficient single-photon detectors. Now, at the season finale on Friday, April 23rd, we welcome you to the Quantum Meeting of the Minds. We are calling for key players along the entire photonic supply chain and will connect them with leading quantum component suppliers, including lasers at specific frequencies, single-photon sources and detectors, integrated photonics for manipulation of atoms and photons, or diamond-based components. And that's not all. We will move up the quantum chain with quantum system integrators, including low-light cameras, time-gated spectroscopy systems, long-range LIDARs, or gravity sensors. Our goal at EPIC is to push forward the industrialization of quantum photonic technologies. Is this in your scope? Contact me now or register to participate in our Zoom room. I can't wait for this season finale. And the waiting is over. We are here and it is the time for this fantastic season finale. For those of you who have a very, very sharp eye on a Friday afternoon, you guys noticed that there was a 600 logo in the video and a 700 logo up here. Yes, indeed. Last week, we achieved a fantastic milestone, which is to reach 700 members. But that means very, 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 very little to us on the day-to-day. We still will always, for as long as we work here, will always know every company, every EPIC member individually. Each one of you is individually important for us. But we are very happy that we are now a family of 700 members. At EPIC, I'm here talking on behalf of a fantastic group of people, 15 people, half of them with a PhD, who dedicate their life to the photonic industry. Together with them, we organize events, we provide access to a network, we help you raise capital. We had the biggest website to have a job in photonics, jobsinphotonics.com, and every EPIC member has access to a long list of market reports. Today is the season finale. It was a great season, but we also received great feedback. people are saying that EPIC should support the quantum industry. So we're going to continue doing that. We're already working on the season 2, in which the 3 first events are already fully announced. Please register as soon as possible. In October, we are addressing atomic clocks and network synchronization with companies that go from space all the way to metropolitan area networks. On the 3rd of November, we are addressing the topic of quantum sensors, especially the topic of gravitometers, in which we saw a huge growth on the last year. And finally, on the 1st of December, the topic that everybody is very interested about, how photonics is going to contribute to large-scale qubit generation, competing with ion or any other way of generating qubits. And also remember that EPIC is a photonic association. So most of our work is on photonic events. And on Monday, for those of you interested in photonic integrated circuit packaging, it's going to be a great event with great speakers. Even Michael Levy is going to be our keynote to Monday. It's going to be a fantastic event. If you want to participate, register as soon as possible, because I think we have already too many companies already in the room. And also today, that was about other events. Today is about connecting. Today is about connecting. This event will be possible without the support of first our media partner, Electro Optics. Thank you so much for all the promotion you are doing of our work. But most important, thank you for the people who are sponsoring the event today. QuTech, all the way from Delft in the Netherlands. This is the leading R&D center in quantum technologies in the world, collaborating with quantum computing companies, bringing R&D technology to quantum real markets. QuTech is an example for R&D centers in quantum technologies. imec, the center all the way from Belgium, the center that enables microelectronics manufacturing, photonics and microelectronics, from quantum technologies all the way to large area, large scale wafer manufacturing for microelectronics. Amin, thank you very much for being with us today. And finally, Senko, or fiber optic interconnect solution provider with 30 years experience in the telecom industry. They are a partner with Kobo, they are a partner with the different associations, also with IEEE, and they Senko managed to bring EPIC together, connecting the fiber optics to many different markets. Thank you, Senko, for being with us today. And thank you to our quantum sweet angel, Dr. Sana Amairi-Pyka. What a season it has been. What amount of hours you have put. What's going to happen in the season finale?
Well, let me tell you, first, thank you for this great introduction, but let me tell you that we will hear from very nice speakers that will give you new opportunities and will give you new ideas, but most importantly, show me the supply chain, Jose. Most importantly, the supply chain that we have. This meeting, like Jose just said, is about connecting. So we will try to hear from all the people that are in the room today. We will try to connect the system integrators, that the great system integrators we have in the room, together with all the component manufacturers, people working on QKD random number generators, photonic integrated circuit, single photon detectors, single photon sources, and all the other parts from lasers to fiber optics and timing, semiconductor manufacturing. And of course, if something is missing, we can always go back to the R&D and push them forward for their research and development. This meeting also we have in the room the European Space Agency, the European Defense Agency, we have the end users. So just make sure you are well connected. And if you are missing your logo, what is the reason, do you think, Jose, if a logo is missing of one of
this slide only corresponds to the companies who registered for this meeting. So indeed, as Sana said, if you are an EPIC member and you miss your logo at this slide, that only means that you forgot to register. Don't let it happen again. epic-asoc.com, all our events are there. Please register as soon as possible. And of course, this meeting and every EPIC online meeting is, of course, free of charge. Because at the end of the day, we are here to provide value to the photonic industry. Sustainability of the photonic industry is our motto. This meeting is also live streaming in YouTube. So hello, YouTubers of the world. Thank you very much for connecting today. If you have any question during the presentation, write so in the chat. Any question that you write there, it will be read in the room. And also, if you want to get in touch with any of the participants today, drop me an email, jose.pozo@epic-asoc.com. I will be more than happy for making that introduction. And this is, of course, also valid for the people with me here in this beautiful afternoon in the Zoom room. Use the internal chat to talk to each other. Use it, abuse it. This meeting is for connecting, but also if after the meeting you didn't get a chance to talk to the right person that you wanted to connect with, drop me an email, jose.pozo@epic-asoc.com, and I will love to make that introduction, because that is what I dedicate my life to. Let's start the meeting. Sana, are you ready?
Absolutely.
I don't notice, I don't feel it. Sana, are you ready?
Yes, I'm ready. Let's
There
start.
she is. Let's start the meeting, and there is no better way of starting this meeting than to go to the leading R&D center in Europe. We are extremely happy of having imec as a member of EPIC. We wanted to start a meeting on supply chain with imec. Amin Abbasi, the epic hero of imec. The floor and the attention of everyone goes to you. Let us help you make imec even greater than already is. Amin, we can't hear you, mostly because you are muted, and I have a mug to celebrate such achievement.
Is it okay now?
Now we can hear you loud and clear.
And the slides are clear.
Yes.
Okay, great. Thank you, Jose, for the introduction. Indeed, it is the pleasure to be here in this quantum event. EPIC is always the best place to just discuss within a community, optical community, and extremely happy to be here. So let me start with this slide about the different technology for for quantum computing. So this is the slide that I really like. It's made by Michael Grech. So he put almost all the technology available for the quantum computing and also corresponding players in the field. So I'm happy to mention that we are working at imec internally on the quantum computing on the based on the spin of the silicon and also superconductor technology. These are in the black circle, but more relevant to the topic here, it is related to photonic. We are already working with a two-player in the photonic domain. We are already engaged with the customer there and also discussing with some potential customer on the trapped ion-based quantum computing. So it shows that how imec is already engaged. And as I have another slide that show also we are our electronic team, our design team also is working on this quantum computing through the European project called Unicorn. So the whole idea of this integrated photonic for quantum application is that you see this slide on the left. It is the brilliant setup of having a quantum computation using optics. But as you can see, you can generate a couple of tens of qubit with this setup. It is with the scientists from China, I believe. And but if you want to make a practical use of quantum computing, you need to make not tens of qubit. You want to make 1,000 or 10,000 or millions of qubit. So clearly, this setup is not scalable. So the direct translation from this setup is the integrated photonic. As we can see on the left, you can generate a almost million times smaller component compared with the free space optics. And this is the potential that I want to bring from the beginning. A quick introduction to imec. imec is the R&D center for the microelectronic, as Jose mentioned, also for nanotechnology. We are using the same infrastructure on the 200 millimeter, 300 millimeter for the CMOS scaling, also for the photonic state-of-the-art clean room, working 24/7 like an industrial almost scale. So we are working on both aspects of quantum key distribution and also quantum computing, less on the quantum sensing. But for the quantum key distribution, as I mentioned, we are participating in a couple of European projects. One good example is this Unicorn. Our electronic team are working on the circuit behind this quantum key distribution. And also we are partnership with the universities in Singapore for the quantum key distribution based on the silicon photonic. And a couple of other examples also here and there that we are working using our photonic platform. On a quantum computation, So we have a building blocks available based on silicon nitride photonic, like a Mach sender interferometer, phase shifters, ring resonator. We believe these are the building blocks that it is used for the photonic-based quantum computing. And why imec? Because we have a state-of-the-art silicon nitride platform on 200 millimeter and 300 millimeter, extremely low loss, and we can. The platform is fully flexible to not only for prototyping and research. We can also handle the volume up to 1,000 wafer. So as you can see, we are just the bridging gap between the academic center toward the more industrial product version. And also low phase noise of silicon nitride, transparent in the visible domain for ion trapping based quantum computing, and also high power handling. So you want to put all these building blocks in a system and make a complicated setup. Cross-section, generic cross-section of the platform. It is a mature platform. We are already running this platform as a product for 4 years, but it is fully flexible. So layers can be adapted based on the customer requirement and the specification. Open the cladding, open the trends for the fiber attach for the hybrid integration with the laser, metal layer for the phase shifting, all are available. And you don't need to start from the scratch. Building blocks already developed. Not also for silicon nitride, for more completed also for silicon photonic. So we are just interchanging the PDK between two platforms. One last slide about imec capability I wanted to bring here. For quantum application, when you want to scale it, uniformity of the wafer, it is extremely important. So we managed to reach to the almost 1 nanometer thickness control over 200 millimeter wafer. So I think this is unique about imec, that we can reach to this level of uniformity, not only on the wafer, on the lot, and basically on the production. So this means relaxed mindset for the designer. When you want to dice the wafer for the small pieces, the dice will almost act similar. And last, I wanted to go fast to just cover this also slide about epic question. What we do, and what we need. We have a platform, 200 millimeter, 300 millimeter CMOS line for both silicon nitride photonic, high-speed component, the state-of-the-art for the data telecom application, but also silicon nitride more for the quantum application. Design capability, simulation, characterization in a wafer scale. What we need, we are in the bottom of the ecosystem, as Jose mentioned, but in order to make a platform even more functional and also appealing, packaging, assembly, laser for the quantum application. We know that it is the special type of laser, photodiode also for quantum application. So if we get our hand in these kind of tools, it could be make the offering and also technology more appealing for the customers. Thank you, Jose.
Thank you so much, Amin, for this very nice talk, and for the last slide where you answer clearly the epic question. I will first take the first. We have already 2 questions in the room. Let me first start with, why don't you just raise your hand? Let's start with the question from Jorn Quicks.
Yes, thanks for. Oh yeah, can I just ask my question?
Yeah, please.
Yeah.
Okay. Hey, nice talk. So what is for us, for example, so what is very interesting is, of course, your advanced silicon and nitride layers for us. Do they come at a cost of, for example, higher losses because it's a different type of nitride?
No, it is the LPCVD. Yeah. It is the LPCVD one, but with special processing technique for the uniformity. But the loss is almost similar to the LPCVD.
Yeah. And then also the big issue for us is always coupling losses. What are the typical coupling losses for 1550 or, for example, at 900 nanometers for quantum dot wavelengths?
For the 1550, typically we say we guarantee below 2 dB. But you know, with the special design, with the packaging, this is more packaging practice. You can reach to the dB or below dB level, but at least it is the part of the design trick. But normally we say with the standard component below 2 dB guaranteed. So I don't want to say crazy number that we don't, but you know, it is about more about not platform. It's about how to design your structure in the interface.
Is there an approach for you to go to crazy numbers? Because I want to hear crazy numbers.
Yes, yeah, it is more about the collaboration with the packaging house and also how to handle the, it is, you know, when we are always looking toward the volume production. So we want to make sure that any processing step that we want to make, it is manufacturable in a wafer scale, and the 200 millimeter for product. So there are some activity at imec not for fiber coupling, for more laser integration, that you can go even to the much lower numbers. So directly laser integration on a wafer scale.
Yeah.
So we can discuss maybe if you are interested.
Absolutely, you should discuss later. Jorn, if you can tell us in one word what is QuICS, what you do at QuICS.
You are muted.
Of course, I'm muted. No, what we have right now is quantum photonic processor, and that also based on silicon nitride, ultra low loss, and also so far the biggest that is commercially available right now, and it's all based on a PIC platform and silicon nitride.
Thank you. Thank you so much. Let me see the second question from CSEM. Amir?
Yes. Hello, Amin. Can you hear me?
Hello.
Hello, Amin.
Yeah, Amir.
Long time no see. How are you? Actually, quick question. So you mentioned about the, thanks very much, by the way, for the amazing talk. So your PDK library that you mentioned you're transferring from silicon nitride, is it only for 1550, or do you have it available for other wavelengths? I mean, you mentioned about 900, but also I want to raise the 780 nanometer to addressing like an atomic cloud and atomic clocks.
Yeah.
You have a standard library for that, or is it?
Yeah, you know, one thing about silicon nitride that it covers so wide range of application. For silicon photonic, we have a full library at 1310 and 1550. For silicon nitride, depending on the customer, the attraction, up to now we had more driver from telecom market. So we have a good library on C-band, O-band. But we are already working on visible domain because that is the more something that silicon photonic cannot do. So we have some mini PDK, let's call it, basic design rule on the visible domain and 900, but not as complete as C-band. So normally we provide this like a cross section of the waveguide, design rules, CDs. So customer need to design based, not start from the very scratch, refractive index uniformity, thickness uniformity, all these things will be available, but maybe not on the really high level as C-band, O-band.
Got it. And maybe a follow-up question: do you have a special, like in your shadow edge, do you have a special thicknesses for this narrower wavelengths?
No, it is just it is fully flexible, so we can stop based on timing any place that customer asks. So it can be fully edged, it can be partially edged. So it is fully flexible.
But I mean, in your MPW, probably you have a defined thing.
Yeah, MPW is fixed. And for the silicon, also for silicon nitride PCVD, we have for life science application, they are fixed. Yeah.
Got it.
Okay, so let's make a deal today. Everybody who asks a question also has to answer the epic question. Amir, you are preparing a pilot line for manufacturing thin lithium niobate photonic integrated circuits. We're extremely excited about this. What is your answer to the famous epic question? What can you do for them? What can they do for you?
Actually, do you want me to share a quick slide, or I can answer it?
Let's go for a quick slide, but ultra fast photonic slide, you know?
Sure. Yeah, indeed. So indeed, thanks. Pozo, can you see my slide?
Crystal clear.
Awesome. Yeah, thank you so much for mentioning. Indeed, I mean, at CSEM, we are trying to actually develop the first foundry, PIC foundry, based on lithium niobate on insulator platform. And just, very very short on like why lithium niobate and insulator is interesting. Lithium niobate is very interesting material. It does no, I mean, it doesn't need any introduction for this community, but it comes with a lot of advantages that is lacking, or it doesn't exist in other platforms. I mean, it's a very good electro-optic platform. We can do very fast modulations. Above 110 gigahertz has been demonstrated with very low BPI. And as a bonus, it comes with a very interesting optical nonlinearities, both QI2 and QI3, that allows us to do very interesting stuff such as frequency conversion, wavelengths, second harmonic generation, supercontinuum generation. And as a bonus, well, lithium niobate actually also has a very large band gap, so we can actually tolerate a lot of optical power, similar to the levels that actually silicon nitride can. That also comes as an additional bonus that you can do it has a very wide transparency window. So we are actually, I mean, we are transparent from 350 to 5.5, and this is the reason I ask, because at CSEM we are developing two platforms in parallel. One at 1550, we are working on a PDK library at 1550, and at 780. And lastly, this optical losses seems to be very promising. We already demonstrated below 0.2 dB per centimeter. We are pushing it more. People have demonstrated a factor of 10 in literature. This is not something we can actually get guaranteed, but we are going there. And lastly, AOMs, like it also a piezoelectric material, so you can actually think about functions such as acousto-optical modulators that we are currently working. So we are trying to actually develop this into a full, sort of platform with a developed PDK, but we are already collaborating with some people. So if you're interested to access this as a pre-commercial sort of access to Foundry, please contact me. I'm happy to collaborate.
I'm extremely excited about the speed that the moderators can achieve, and the VPI below 1 volt was a much needed technology, as you saw in our meeting beyond 400G last Wednesday. My money is on you. Just make sure, all EPIC members, make sure that we can help to have a foundry on lithium niobate in Europe. We need to do it. So get in touch with Amir. You can provide any help with the PDK, any testing, any packaging solutions, or you just have some crazy applications that need ultra high speed modulation. Amir is your man, and I will be so happy to make a connection. I want to go back to Jorn Epping. I want to go back to QuICs, because this is one of the success stories that we have in Europe. You cannot escape without answering the EPIC question. I'm very excited. You already have on chip 12 mode operation, quantum computing operation already proved. What is your answer to the EPIC question? What do you need for the community?
So what we are looking for is always, of course, lower losses, because I think I heard someone tell that every photon counts. And what else?
You need customers to provide algorithms.
Algorithms, we are always, that's really a big thing we are working on. What we're interested in, use cases and people together to develop algorithms on our platform. That is.
I am very excited about having already a proof of concept on a quantum computing on photonic integrated circuit on the room on QuICs. Congratulations on what you are achieving. Once again, if anybody wants to try this platform for solving a real quantum problem, contact Jorn. Here we have an opportunity of being really, really innovators in the room. Later on, I'm going to go to other companies who can help you, like we have in the room, like LIGENTEC and QuTech. But before that, we talk about a little bit of photonic integration. I want you to now see how electron beam lithography, E-beam, can help your business. For that, we had the leading E-beam expertise in the room. Kelvin Nanotechnology, a success story by itself, but also helping many companies in the quantum business. My friend David Burt is here with us to tell us how Kelvin Nanotechnology can help you with the E-beam lithography solutions. The floor and the attention of everyone goes to Glasgow, goes to you.
Okay, thank you very much, Jose. It's fantastic. Thank you very much. Very kind introduction. You might have noticed a few pictures have changed just recently on the website. Brendan, KCR CEO, was due to present here today. He unfortunately, something just came up. He sends his apologies, but he does intend to join us later on for the discussion. So if we can join him in, that'd be great. So I'm Dave Burt. I'm the business development manager at Kelvin Nanotechnology. And in my role, I've been involved in a whole range of technology development across the company for 9 years now. In particular, coordinating many of the quantum technology innovation activities at K&T. So a little bit of background about us. We are a globally recognized provider of advanced photonics and quantum components. We were established in 1997 in Glasgow in the UK. We are the commercial arm of the James Watt Nanofabrication Centre at the University of Glasgow. And within this cleanroom facility, we process above 1,000 wafers per year. And over the years, we've built up a global blue chip customer base. Being heavily involved in photonics and innovation, we're qualified global photonics supply chain partners and also have been partners in 12 Innovate UK quantum projects, and within partners in over £50 million worth of innovation projects as well. So our three core services on the right-hand side: electron beam lithography. So we have multiple electron beam lithography tools for production services, but this tool can also be used to provide a route to really versatile nano patterning for a vast range of applications. We also offer prototyping services. This includes the fabrication of very complex devices processed across various different material systems and with a range of dimensions from tens of nanometers upwards. And finally, we produce components where we're developing a portfolio of innovative devices ranging from metrology sensors to quantum components. So we've been supplying components for quantum systems since 2013. And that has been to OEMs, academia, national measurement and standards institutions. And on this slide, here are some of the examples that we've developed with partners over recent years. And all this work that they've brought to us has stemmed from work that's originally published in very high impact journals, largely in the sort of Nature journal family. These include, on the right-hand side, we've got the magneto-optical trap gratings. This work was led by the University of Strathclyde. It is a diffractive optical element. It's about 1 inch in edge length and size. And the great thing about this technology is that it improves the ease of alignment, the setup, and the miniaturization for creating a cold atom source compared to what people are conventionally used to on the 6-beam MOTS. This grating technology is being combined with other miniature optics and vacuum components to provide a miniature magneto-optical trap system. And this kind of serves as quite a nice example of the level of miniature integration that we need to achieve when you think of the size of this being about 1 inch. On the bottom right, we have the Ouija portable gravimeter. This work was originally published by the University of Glasgow, and it's a MEMS technology that could be applied to a broad range of applications and could serve as a complementary low-power reference device for quantum gravimeters. And then finally, on the bottom left, we have microfabricated ion traps. This work was led by the National Physical Laboratory, and these devices enable the trapping of multiple ions and form the foundations of future quantum computers. But as you can imagine, it requires some very complex optical integration to scale up. So for our view, the future of quantum systems is in miniaturization, scalability, and industrialization of components, which lie at the heart of these systems. Photonics is an underpinning technology for quantum in devices and integration, but it can offer so much more to the quantum supply chain. Photonics is well established, and there's a huge amount of expertise in integration, reliability, packaging, etc., that could be brought to bear to expedite the commercial deployment of quantum technologies. And these will find applications in a broad range of areas, including data networks, navigation, and computing, as you're all aware. So that's the end. Thank you very much.
Thank you so much for this nice talk. I would like to see first if we have any questions in the room. You can unmute. And I will see your question. Otherwise, can I know more about your request to the EPIC team, like develop on your on what you want from the others?
So what we need is information really from higher level system integrators and packaging companies as well, optics integration systems as well, about how some of our miniature systems could then be built up into, along with their capability to then produce larger subsystems and so on and get bigger still. So that's really, the key stuff from that side of things.
I think Gregory from QuTech would like to comment. Gregory, can you unmute and tell us what you do at QuTech? I mean, I think.
Hi, David. Thanks for the talk. I'm totally unprepared. I had no idea I was going to make a comment at this point in time, but it doesn't matter. I do have a question, and that is, David. So, have you been speaking to any, let's say, MEMS integration services already?
For some, yes, we have, yeah.
With or without success?
Sort of mixture. So sometimes, we'll find that certain ones will be able to help us develop certain components, but it's not necessarily everything that you'd want from, what your aspirations are. But again, we're very interested in, getting to know other people that can help with that type of process and scaling up. That's the key thing, is really, taking it from a small scale up to the larger scale with better automation.
That's probably something very much that we would like to be interested in, or would like to get involved in. I'll drop you a line. Thank you.
Perfect. Thank you.
Okay. Let me ask you a question. Did you check on the how robust are these systems? Can they be used, for example, in space, on aeronautic system, and so on?
So at the moment, they're in development. For some of them are in development. The grating chips can be bought now. They are very robust, well, as robust as pieces of silicon would be. And then some of the vacuum technology as well is being developed with that type of application in mind. So yeah, we're fully aware that that's a good area.
Yeah, great. Let me see if Jose has a comment.
First of all, I would like to congratulate KNT. This is based on almost 30 years old expertise from University of Glasgow. They manufactured my first quantum chips already when I was at Bristol University 20 years ago. So that was really quite amazing then, and they have grown into becoming an iconic solution. I want more companies to work with you. So I'm going to check in the room some people who perhaps can help, can be user of e-beam solutions. Let me have a look at who I have in the room. I have people from Lausanne, I believe. There's a company called LIGENTEC providing silicon nitride photonic integrated circuits. Do we have anybody from LIGENTEC in the room? I believe so. We have no other than the Director General, Michael Geiselmann. Michael, thank you very much for being with us. First of all, you provide silicon nitride photonic integrated circuits for the industry. You are a pure play foundry on that. What is your answer to the EPIC question? What can they do for you? What can you do for them?
I can show 2 slides here on that. So
of course, I always say one thing: ultra fast photonic presentation, please. Ultra
fast photonic, yeah. So what we're based in Lausanne. We provide silicon nitride photonic integrated circuits. And recently, a customer of us, Xanadu, has actually shown how to use those in quantum computation. Actually, they fabricated a chip with us where they used our AegiQ resonators to create squeezing on a chip. So that's quantum entanglement on our photonic integrated circuit at room temperature. Then filter out the pump light, and then have a big interferometer with heaters to do the actual quantum computing. And they run in that paper here. They run 3 different algorithms on that chip and showed room temperature quantum computing on a PIC. So we're very happy to have that, and based on that we yes, as you said, we're offering silicon nitride photonic integrated circuits to the community with a high mode confinement that allows this, for example, squeezing of a light, or also frequency comb generation. We have a very low loss and established PDK, and are very well aware of world connections, so have low loss I/O couplers and integration methods to get also actives on the chip. And as for your question in terms of e-beam, there is some high-end applications coming from time to time that need very small structures. It is always a question, as we're working with DPV lithography, it is always a question: do we do that mix and match with two technologies or not? And so it is more a question of how big the volumes are and how big the NRE can be that this is possible. But mix and match is definitely an option to address customers that need very high resolution down to the nanometer level with e-beam.
Actually, on that, Michael, David has a lot of good stories to share, because when it comes to solving stitching errors, they have worked very highly with Wraith, right, David? How do you address combining different lithography solutions and having zero stitching errors?
In terms of level-to-level alignment, there was a lot of development. It's some years ago now, actually, it must be over 10 years ago, in terms of the ability to define specialized e-beam markers, which allow you to get down from what would be normal for a sort of tool, I don't know, 10, 15 nanometers, you could get down to the nanometer level, actually nanometer level of layer-to-layer alignment.
Kelvin, Nanotechnology, David, Burt, you are really one of the companies that make us proud of being EPIC. The way that you are working with many companies is something that we love. Let's try to move up a little bit higher in the value chain. I want to go to one company that is taking today the role of end user. It's called Buy Systems. Henry White, you wrote a fantastic comment, but I was actually thinking of giving you the floor by now. Tell us what you have in mind, and then afterwards, please answer the EPIC question.
Hi, Jose. Yeah, good to be part of this. Yeah, I mean, as always, I mean, that David's presentation shows some really good stuff there, and all the other presentations are as well. One of the problems as BA systems, so we are a final end user, will integrate complete sensing systems, timing systems, communication systems. What we really need is to see an easier way of taking these components and getting them demonstrated to the likes of ourselves as complete systems. So what we often see is there's a challenge of going from the demonstration of the capability to the demonstration of something that's deployable. So is that a question to most people who are developing the components is, what could we do more to help drive that process? Because that's what we'd like to see as a route to helping people demonstrate at the system level, because until we see that shown, it's very hard for us to put our money into these places. So what can we do? We should be able to help provide information about the requirements we have and the types of systems that we need to see demonstrated so that we can invest in the future. And what we'd like to see is people finding ways of actually demonstrating more integrated systems for us in the future. Now, I know, there's going to be so many different ranges of technology shown today at different stages, but that's the general approach that we'd like to see and help with.
Thank you very much. There are two success stories in the room. That I want to ask them to answer your question. We have AegiQ and Quandela. And I'm going to go first. To which one? One or two? AegiQ first. Scott is here. Scott Dufferwiel is here from AegiQ. The question is very simple. We have seen by now that we develop fantastic components. How do we go to the market? AegiQ, congratulations first on all the awards that you are getting. AegiQ is a success story on bringing the single photon generation to different applications all the way to space. Scott, answer the EPIC question and give some comments to Buy Systems.
Yeah, thank you very much, and thank you, Ben, for organising this incredible event. So I'm Scott, so I'm CTO of AegiQ. So at the moment, we are a component supplier, so we're a single-photon source supplier. So I'll just splash up my screen if that's okay.
Of course. Remember, this meeting is about connecting.
Yeah, absolutely. Just to give it a look, is that appeared there? Yeah.
Perfect.
So what we do is we do quantum photonic systems based on deterministic sources of light. So our primary technology here as a component supplier is the use of these deterministic sources of indistinguishable photons. And what we can offer to the community here is turnkey operation, offering in multiple wavelength bands, 1 at 9, 10, and probably the more interesting one based on our indium phosphide platform, operating in the telecommunication wavelength. So while AegiQ itself is focused on quantum communications, we see a very nice market opportunity. And again, this goes back to the comment from BAE about how we take this to market. There's actually the route towards there is a very nice market opportunity. And specifically, there's a current need and requirement for single photon sources for a wide range of applications in quantum communications and imaging and microscopy, multi-photon imaging and photonic quantum computing. So we are offering this at the market at the moment. And in terms of what the larger systems integrators can offer and guide in this and how we take it there, the key thing we want to understand as this component supplier is customer pain points and system integrator pain points. So how do we adapt our systems as we go through this development into making sure that at the end of this, we can integrate it to a larger system that someone like BAE would be able to adopt. And I think that's kind of key to kind of our development here. This constant feedback and iteration on developing these really high-tech technologies and how we can adapt them and interface them with these future systems that are being developed.
You're one of the success stories of the indium phosphide manufacturing in Europe, and you managed to go from a technology that's getting mature all the way to already providing solutions to the space and to the defense sector. But Henry, that's not all. We have another one. We have Quandela in the room. Valérian, looking great today. Valérian, tell us. So you also develop single photon sources, but tell us what you do, but most important, the epic question, because today is about connecting. How can the others help you? Well, you are muted. So I'll show you my map, and actually I'll send you one of those.
Good afternoon, everybody. Sorry, let me try to share the screen very quickly. I have to say I'm very impressed by what AegiQ had just presented, actually. I'm very, very curious. So I also would like to present single photon technology based on more or less the same as AegiQ. We are using quantum dots in micro pillars, and we are fibering these pillars such that we reach high optical efficiency, knowing that if we reach an efficiency greater than 2/3, then it will be easy to, well, not easy, but feasible to develop linear optical quantum computing according to some theoretical papers, as we cited here. So you can see that the block points now we have well improved the technology to reach 0.5 optical efficiency of our devices that are available. And actually, we have already delivered some devices all around the world, in University of Brisbane, University of Moscow, Russia, and now we also have customers Netherlands, Italy, and Austria. I'm very proud to have a technologies that can be installed in external facilities. And to answer your question, Jose, actually we have great expectations with EPIC. I can see all around the table here a lot of providers and partners that we are looking for. For example, I'm very interested in the QX technology. One day, sooner or later, but I hope soon, we will try to play with the circuits developed by QX. I hope very soon. So I will contact Jörn to discuss more about this. I've heard that he already sold one system. I hope we will be the second. Also, we are also looking for, as you know, very short pulsed laser diodes of about 10 picoseconds at the wavelengths of 920 nanometers. If anyone in the room knows someone. 920 nanometers.
920.
Yes, 10 picoseconds. Now, yeah, exactly. So that's it. Well, it's always a pleasure to
No, that's not it, Valérian. I'm going to come back to you later because I'm going to find you that laser, but also there's more things that we need to answer. But I want to go back to Henry. You know, Henry, this is our 6th quantum technology meeting today. And my learning point is that technology is moving faster than we anticipated. I see that the QuickTech already is looking for companies with software problems to solve at their platform. I see that Quandela already in a few years have managed to deploy systems worldwide. I see that the defense and security sector is leading on market uptake. So I would like to ask you something related to maybe long-range LIDAR applications. Is there any particular need, challenge, or perhaps some room for cooperation, an item in your Santa Claus Christmas list?
Well, yeah, I mean, the long-range LiDAR is a really interesting area for us. And actually, so the challenges and the improvements we like to see is, can we move that into longer wave infrared areas as well? That would be really interesting for us for greater penetration through the atmosphere. And the other challenge we have for BAE Systems, for especially in the air sector, fast-moving platforms. So we don't have a long integration time. And what we want to do is maximize field of view, dwell time, and actually sensitivity. So it's the technology is out there, but there's still improvements in all those areas about performance, which will make it easier to deploy. And as with any technology on a platform, it almost has to buy its way into, because the space and the power is always limited. So those are the real challenges at the moment.
We are going to come back to you with the challenges, but I wanted you to give this introduction because the best meeting of the season was the one that we cannot share, the one that we organized on security and defense. But one of the best contributors to that meeting is here today with us, representing the US Air Force and looking for partnerships in collaborating, developing quantum technologies. I had the honor and pleasure to present Boyan. Thank you very much for being here as the Program Officer of Atomic and Molecular Physics for the US Air Force. The floor and the attention of everyone, because we all want to collaborate with you, goes to you. Thank you.
Thank you, Jose and Sana, for the opportunity to be here. I will start with a small correction. Can you folks see my screen?
Yes, but not with the quality we would like. Maybe you can press Control L.
Control.
Yes, now much better. The floor is yours.
Right. So I am a program officer, but not for the whole Air Force. I'm a program officer for the Office of Scientific Research, which is the wing of the Air Force that focuses on basic research. So my objective today is to tell you about some opportunities to engage with us and tell you a little bit about ourselves as well. So we are a military organization. We are a part of the Department of Defense, and this is reflected in our mission and vision. But as I pointed out, our main object is discovering science that is going to change the future, the science that is going to lead to this fascinating work that you have demonstrated here. And let me tell you a little bit about where we are. So we have so-called technical directorates in different parts of the United States. And the one with the star is where I sit in principle in Arlington, Virginia. And those technical directorates have different objectives. And some of them may be open to international partnerships, and some of them may not. We certainly are. In fact, we have a vast spectrum of interests ranging from aerodynamics and propulsion all the way to bioscience. The atomic and molecular physics portfolio is in the bottom left corner. It is only a small fraction of all that AFOSR is interested in. Where do we do this? Well, we tend to be all over the world. In fact, we have almost 300 international efforts in almost 40 countries. I think the only continent that we do not have an effort in is Antarctica. In particular, we have quite heavy presence in Europe through either our office or the AOR office, which is based in England. And it is a branch that handles local research, usually. Right. So how do you find us? Well, there is this website, grants.gov, which lists opportunities. And the specific opportunities for basic research are under this starred announcement here, which lists the way to engage with us and also the folks to contact if you're interested in pursuing basic research opportunities. So with that, I'm going to point you to a different star on the map. As I mentioned, there are different directorates with different objectives and different venues for doing business with folks outside of the US. And one of those directorates is the Information Directorate in Rome, New York. And over there, folks recently entered into partnership with multiple state and local organizations to put together this open innovation campus, or now it is known as the Innovare Advancement Center. So the objective here is to allow collaboration between international partners and us into a facility that is maintained by a partnership between the Air Force and local governments. So one of the ideas here is to have a test bed. For example, if you do ion trapping and you wanted to test out some component, one idea would be to just go there and try this out. This facility is in its very early stages of development, and I invite you to visit their website and seek contact directly with folks there. But long-term, this is where they want to go. And with that, I will open it to any questions.
Thank you so much, Boyan. But let me give you the first question that you are expecting, I guess. This is the epic question. So we heard the first answer, what you can do for the others. And thank you for sharing this opportunity with the members and the guests. But tell us, what can the others do for you? Can you give some business opportunity as a researcher? Are there some systems you're looking for, specific detectors, lasers, and so on?
So as a basic research organization, FOSR is interested in research that is high risk and high return. It is the very definition of basic research that we are after. So we are interested in your ideas that you believe are going to change this world after they mature into production. So it is that crazy idea that you think is going to revolutionize our life that we're interested in.
Jose, I see that you want to say something.
I always do, but this time I really need to, because after the previous meeting, we introduced you to many companies who wanted to follow up, and you had follow-up discussions with all of them. There is an incubator program, right? There is an incubator program in which the companies can actually get some joint development funds to cooperate. Is that correct?
I'm not sure which program you're referring to, but in general, both FOSR does have opportunities for everyone to engage.
Okay, we will, maybe the question was poorly formulated. We do want you to interact with them. There is something which maybe we cannot say in YouTube Live, but there is something that we can interact with and a great opportunity for collaboration here. I am very excited to see that you are collaborating with many, many different companies. I'm also very excited you're collaborating for some challenges. In the previous meeting, which was of course a private one, we discussed a few of these application fields. For me, the key question here is that as a basic research organization, the maturing of the technology is something that should be in your concern. And how do you address when a technology is mature to be deployed in a end user location? And how do you make this maturing of the technology? How can you help a company like Freedom Photonics, a one-stop shop of photonic integrated circuits in the room, maturing the technology to serve the defense sector?
I believe that this is left to businesses in general. We stimulate interest in businesses to develop technology, and if it ends up being applicable to situations, then maybe we support this. And this is, of course, a very personal opinion. This is not a statement on behalf of the DoD.
That's always has to be in mind. I want to address this. And we have a person in the room whose blog I really, really like. If you have telecomforesight.com, have a look at that blog. It's really, truly fantastic on how he analyzes the different telecom sectors and merge that are happening there. But Don Clark is with us today as a consultant, telling us a bit about how to mature technologies. You had a very interesting comment in the chat. Speak your mind and give us some light on how we can mature the technology of quantum to serve the end user applications of biosystems and the US Air Force.
Thanks, Jose. So I'm not an expert on quantum computing, and it's a long time since I did photonics research, actually, back at BT. These days, I'm an independent consultant, but I still work with some of my colleagues in the telecom industry. Marcus and I know each other really well. What we've been trying to do, and it's all voluntary, we're not paid to do this, I'm not selling anything on here, is we're trying to bring some of the insights that we've learned from working with small leading edge companies in our careers in telecom R&D. And Marcus, you might want to add something from your experience at Swisscom. But engaging back in the day in the photonics with optical access, the challenge for us was how do we determine that the technology is mature enough to be deployable at scale and in the telecom network, right? In telecom network, once it's deployed, it has to be reliable. Particularly with things like quantum key distribution, it's got to be absolutely reliable. We can't have banking transactions failing because our network isn't working properly. So, there's a lot of companies in this space, and it's incredibly impressive that there are 700 companies involved in EPIC. The question then is, how does a telecom operator who has a end user requirement, let's say for a banking transaction system, who's he going to work with? Does he work with just the big vendors? But noticing how many small companies are on here that are really innovative. You've got some fantastic researchers, University of Glasgow, I heard earlier. First of all, who does the telecom operator work with, right? And then once they work with those small vendors, putting together some kind of demonstration system, how do we determine that thing is actually reliable and what? That's just a technical challenge. But for the small startup, who do you choose to work with, right? Because once you are in a space, trust me, there's going to be 20 different companies that want to work with you. Which one do you choose to work with? You can't work with everybody. So that's one thing that you have to work out. And then if you do choose somebody, how can you be sure that that end user is going to be serious about deploying the solution that he's getting you to demonstrate, right? So I think all I want to really say now is that I put up in the chat a link to the telecom ecosystem group. We're just 4 or 5 guys, and actually Caroline Chappelle, she's a lady, works for Analysis Mason. We're doing it voluntarily, and this is about just putting out there what we think are some guidelines and lessons for you. So if you're a startup company, have a look at some of the stuff there, and they're the pitfalls you're going to encounter as soon as you start talking to a big network operator or a big entity like a bank, to make sure that you watch out for them wasting your time and that you also help them help you figure out how you're going to be successful with it.
Thank you. First of all, thank you for the blog. And one can you post? It's been already a couple of months. And also, thank you very much for being here representing the telecom operator sector. We have Biosystem, Air Force, and Don Clark from Telecom Foresight asking a little bit about this maturing of the technology. How do they contact? They have the young startup. How do get the technology of the young startup into the market? On that, I need the views. I need the views of Case Eichel. Why? Because QuTech really positioned themselves as basic research, but cooperating with TNO, they really managed to bring the research to industrial applications. Case, can you answer the question of Don and also a little bit the questions of Henry and the question of Mr. Tabak? How can we bring the technology of these young startups to real-world solving applications?
Yeah, but thank you very much, Jose. Indeed, this is a challenge for everybody. At the end of the road, you have users who want reliable technology. Today, you have promises mostly, and we got great technology moving forward. And how those two will connect is still an open question. And we need to work from both sides. And that's why an approach, a connected approach, and a lot of interaction is essential. So first of all, thank you for bringing these groups together, because it's exactly what EPIC does. We do the same also in our programs and regionally. So as an institute, we focus at scalable technology development. So we want computing and internet systems, quantum communication systems to be, let's say, brought up from the research side in a scalable fashion. We try to build full stack stuff that is at least has the promise of scalability and reliability. But that is only going to be proven when someone is starting to use it. So what we do is a number of things. First of all, demonstrator, testbed kind of environments where people can buy into and work with from all sides. Secondly, a lot of, let's say, transfer and spin out and, let's say, economic activity around us that is strongly connected to our programs so that we influence one another. So in effect, our research agenda is also strongly influenced by how the field is progressing on a daily basis, and we respond to that on a daily basis. So I think those two, connecting your strategy with others and also creating something in the middle, and we call them testbeds or demonstrators, in which we can connect to our industrial partners and the users. I think those two approaches are for us central. On the photonics side, we are, coming from not specifically from a photonics area, but we are venturing into the photonics area more and more, because our challenges are not only, mastering the physics, but our challenges are also arriving at reliable, scalable systems. And so things like integrated photonics will matter to the further commercialization of our technologies. And so the connection is now stronger and stronger, being, let's say, chased by us to find the right connections to move further on that topic.
In case you mentioned the right word, test beds, and on that I am very happy to see that Europe really is excelling. There are places all around Europe to test your technology into real use cases, and that, Don Clark, is something that we need to push to the limit. OpenQKD, Google that. You will be really truly amazed what the European Commission has put together. But Don Clark, Boyan, and Henry White, I am going to build a story with that. We start from QuTech. I'm going to go now to M-Square. Why? Because they are a laser provider who manages to make quantum gravitometers. Thomas, from M-Square, how do you answer this challenge that is put on the table? We are component manufacturers and we need to provide mature quantum systems. How do we address the supply chain? Thomas, tell us your story.
Thank you, Jose, for the kind introduction. Yes, we are the other company from Glasgow, UK, so to say. Greetings to our friends from Kelvin. Let me share one slide addressing that here. That gives you some impression how we are addressing that, coming from being a laser manufacturer based on solid-state laser technology, now also addressing and making ourselves visible to the market, that we can also do the integration for very important points here. As you can shown here, this is something that we really proud of to demonstrate that we have in the size of a CubeSat, so to say, gravimeters demonstrated proposed. This is precisely the way how you could move forward to the industry, as we had the previous discussion, yeah? How to convince the market, how to find the right customer. The way is, with respect to the telecom thing, is qualification. You have to go to qualify your product, of course, each one on your own value chain position, so to say. This is a way how to do that. Yeah, in case you could grab a defense program or an ESA program, you have to demonstrate qualification data from your product, from your service. This is a way to convince your next step, your customer base on that topic. Yeah,
and this is interesting for the aerospace sector. Very interesting for the aerospace sector. So let me find you the company with whom you need to interact with. Do we have anybody from the leading aerospace sector company, Leonardo, in the room? Massimiliano Dispenza. Grazie mille for being here with us. Thomas, do you know Massimiliano Dispenza from Leonardo before?
No, the company, of course, but not in person. I'm happy to hear from him, yeah, of course.
So, Massimiliano, I see a technology of Thomas. They manufacture something that looks fantastic as a gravitometer, but it's not the shape form that Leonardo wants it for integrating in their product. It's a beautiful big box. Sorry, Thomas. How can we work together, the end user and the system supplier, who is also a component supplier, to make this into a plane?
Yeah, the point is precisely addressing the EP question, so to say. But we would like to look, what we would like to explore is, of course, how we can shrink these things, yeah, these demonstrators, to come up with a real service, with a real product, so to say. This is what we are trying to find out in combination and collaboration with all the parties and members here present, working all together in EPIC. And the other part of the question is, of course, what could we provide to the market? I think we are very well positioned to provide the purest light of all kinds whenever it comes to quantum manipulation of atoms and ions of all kinds. And we can address the whole wavelength range in a very precise, cutting-edge specification.
Quantum is strong in Europe because of companies like M². You managed to really prove to people with real-life demonstrators. But I think we are having sound problems to hear Massimiliano. Yes, my team is going to contact you to make sure we solve this, because I really want your vision in this meeting. Before that, I believe that we found the laser for Quandela. Do you guys know about VEXELs, vertical external cavity surface emitting lasers? I do, and I love them. Mircea Ghina, all the way from Tampere, CEO of VEXLUM. What do you do? And can you help the challenge on the table laid by Quandela?
Hi, Jose. Can you hear me?
Loud and clear.
Yeah, thank you very much. So just me, yeah, all the way from Tampere, just me correct a bit. So CSO, executive chairman, we are changing. I mean, it's Jussi-Pekka who is the CEO and my partner in VEXLUM. So thank you for the opportunity. If I can share one slide.
Ultra-fast photonics.
Which is, or maybe two, which is actually the updated slide which I gave. Can you see it now?
Not yet. It's still in Tampere.
Okay. It's the updated slide which I gave from in our first quantum technology seminar, where we had a longer presentation. So it's updated with our latest platform of single frequency VEXELs. So VEXELs are external cavity surface emitting lasers with gain media provided by semiconductor. They are similar to many solid state lasers, but we have the ability to tailor the wavelengths to almost anywhere where semiconductor works. And we have been doing that as a research at the ORC group for more than 15 years. And a couple of years back, we established VEXLUM, and we are moving fast on solving a big need, practical lasers for ion trapping, with wavelengths on demand, delivering single frequency at watt level. And why this slide is updated, if you check compare it to the presentation we had, we were announcing then fundamental frequency in a rather broad wavelength range at infrared, and we were saying that we are working on intracavity frequency doubling. We have been already developed those now, and we have, well, as you see here on the right, this is a blue laser delivering watt level single frequency kilohertz, 100 kilohertz line width tunable. And these lasers have been now deployed for quite a few lines in the ion trapping community. We started with sodium, then magnesium, beryllium. We have soon a publication coming up with a group working on cadmium and strontium. We have orders for developing for ytterbium, and basically this is what we do. Let me just put one more slide, because it's the same relevant slide what I showed then, and you asked. So seeing the previous meeting, which was, I don't know, half a year back, so we were seeing the need to engage with more ion trapping groups in Europe. This already happens. So there are quite a few groups now taking our lasers in test. There is, of course, opportunity to do more. There is still room for working in partnership with people developing or using lasers in quantum technology systems and providing part of the electronics, what we are not currently doing in laser stabilization and wave and locking and wavelength locking and so on. And yes, I'm saying that we really try to move even more. So you see the box, it's a shoe size box now, what we deliver, this quad level single frequency with control electronics. We are making very strong steps towards OEM version to solve some of the problems what we have just heard, how we can move to higher level system integration. And I have to stop here. Thank you very much.
Thank you very much, Misha. So at the end of the day, I want you to get in touch with each other after the meeting, but most important, Giesz Eicher from QuTech. He wants to interact further with companies in the ion trapping business. Is there a way that you could connect, because I love connecting, is there a way that you could connect this with the people in QuTech developing this? I know there is a postdoc, Joe Randall, who is in the group of Wilfried Heisinger. Is there a way that you could make this connection?
We are very supportive towards research community or developing something new. Ourselves, we are not focusing on the application now. Let's say we have been working traditionally with a NIST group in Boulder. They have used many of our lasers. As you will see, there will be results coming up from Italy, from Germany, using our lasers.
I'm going to find you a new partner. I'm going to find you a partner in Delft. So, Giesz, I know that there is a lot of work in Delft about ion trapping based quantum computing. Do you have some information about that? And how is the interaction that you are doing with the University of Sussex?
Thank you, Jose. I think you're a little bit mistaken. We don't do a lot on ion traps. We do a lot on the stack of quantum computing and a lot on the control electronics and everything above that. And we got this great already online quantum computer available, which is called Quantum Inspire. And you can program on it already since a year, and we're building next version already. And that platform is open to also, and we've discussed that with a number of partners already. It's open to show other, let's say, solutions, hardware solutions, and open them up to the world. So basically, as a European partner, we want to, we got this stuff available so people can log in and they can program, and we're connected to a number of programming platforms. And also at the bottom of it, which ion traps or spin qubits transponders are behind it, we don't really care. So I think that might be a connection opportunity.
Thank you very much, Giesz, for this, and thank you, Misha, and all of you for a fantastic Q&A. We go to the next presenter now. James Grieve is the principal investigator on quantum computing at the Technology Innovation Institute. This institute has received quite decent, I don't know if I can exaggerate or not, but quite decent amount of funding to set up a quantum lab, and they're looking for suppliers. So there is no better way than to knock on the EPIC door and looking for those suppliers in our network. James, thank you very much for being with us all the way from beautiful Israel. I'm so jealous that almost all of you are vaccinated. The floor is yours.
Okay, James is from Abu Dhabi, actually.
Yes, not quite Israel.
Also, many people vaccinated there.
They are now speaking to each other, so that's an improvement, right? So, yes, thank you very much for the introduction, and thank you for inviting me. I feel a bit out of place here since I haven't been in Europe for quite some time now, so I'm kind of the non-European side of all this, I guess. But perhaps I can have share some insights on sort of the quantum technologies and opportunities for the supply chain outside of Europe in places like here I am in the United Arab Emirates. And I've just spent the last sort of 9 years or so in Singapore. So I have a kind of Southeast Asian or Middle East and North Africa kind of perspective at this point, I guess. So as you say, I'm here representing the Technology Innovation Institute, specifically the Quantum Research Center at the Technology Innovation Institute. And as you say, it's a new research center that's just been set up here in Abu Dhabi. So I'm going to try and move to my next slide, which, there we go, cool. So my slides are deliberately very, very sparse and very kind of empty. And I make a point here because we're quite new. We haven't really done anything yet. So I didn't want to show loads of fancy pictures and graphics of what we'd like to do because I prefer to do those things and then show them to you, right? So we start out with just some plain white slides, right? But I thought I would say a little bit about who we are and what our aspirations are. So I'll start out by introducing the Quantum Research Center. So I'll say, of course, we're based in Abu Dhabi, in the UAE. Abu Dhabi is the capital of the United Arab Emirates, which is a small country located on the sort of Gulf of Arabia, just on the Arabian Gulf, bordering with Saudi and Oman and Yemen. So we're a research institute under the umbrella of what's called the Advanced Technology Research Council. This is a new research council that's been set up in the UAE with the kind of remit of spurring development of advanced technology and kind of basic research in the UAE. So the TII has 7 research centers, of which quantum is just one. The other ones are autonomous robotics, directed energy, advanced materials, cryptography, digital security, and secure systems. And I have an asterisk next to 7 because I understand that there may be future expansion to other areas, but this is the 7 sort of founding centers. And all of this kicked off somewhere towards the start of 2020. Different centers came online at different times. So, for example, in the Quantum Research Center, we kind of really got rolling in the summer of last year, and we had all PIs had joined the center by late 2020. So we got up to full numbers sometime in December, I think. So within the Quantum Research Center itself, we have 6 different experimental groups, 6 groups, 3 experimental groups, 2 theory and 1 middleware. Middleware being, let me say, classical computing and algorithms and so on to support the quantum side, right? So I guess you may have heard of Kibo, which is this new quantum language for simulating quantum circuits and also for programming quantum computers. And that's under development at the moment, and that's our middleware group's primary output at the moment. So, of course, I'm not one of those guys. I'm an experimentalist. So the experimental groups are quantum communication, sensing, and computation, which is the sort of traditional split in the quantum world. So we've got our 3 labs set up like that. And at the moment, the experimental groups, we're in the kind of recruitment stage. Our physical labs are undergoing fit-out works. So we do have some physical labs, but they're not quite ready yet. So we're kind of in that stage. And I should say that at the moment, all of our significant procurement is complete. I mean, kind of long lead time for the first year or 2. So we've done a load of procurement there, a lot of it from Europe, actually. And most of it at this stage has even been delivered. So it's just kind of in storage waiting for the renovations of the labs to be complete. I can give you a real quick idea of what we're planning to do in the quantum communications lab. So we have kind of 3 primary research directions we're going to explore out here. Of course, we're going to do quantum key distribution because there's a kind of applied bent here. So this is something that I think everyone contends with around the world. But the people funding you want to see some, basically immediate real-world application. And quantum key distribution, being a fairly mature field at this point, seems like a good opportunity to show that we're able to do something which can really contribute to society quickly. So the plan here is to quickly spin up some practical systems and do some field tests. Also, we're interested in this development of a kind of domestic QKD capabilities for the UAE. So this kind of means we're not interested in buying turnkey QKD systems. We're going to develop our systems here, but of course, we're not going to develop everything from sand upwards, right? So we are still going to be buying components and so on. So we're looking to kind of source for that. We also hope to act as a kind of regional focus for QKD research and know-how. So the idea is that, of course, in a future full of quantum computers, people are going to be interested in this kind of thing, and it's going to be relevant to most countries, right? But we feel there's a place for countries outside of Europe and outside of North America and outside of China to collaborate on this. And that's, I guess, where we hope that the UAE and to some extent also Singapore, where I've just left, the plan is that we can kind of contribute in this way, right? Other research directions are on-chip light sources. So specifically, we're interested in pair sources and single-photon sources on-chip. So we'll possibly use multiplexed pair sources to produce single-photon sources, or possibly heterogeneous integration of emitters onto chips and so on. So the plan here is to basically, we're going to try a few different approaches. I think I've secured collaborations for most of these at the moment, and indeed with some foundries. I should probably talk to the foundries that are present here as well offline. If I haven't spoken to you guys already, I will do. But yeah, the plan is to try several different approaches to start with and see which ones show the most promise, of course, because different research contexts and environments will have different, let's say, different strengths, right? So it might turn out that for some reason working on pair sources here in Abu Dhabi is a non-starter, in which case maybe the single photon source will work better. So we're going to approach a few of these in parallel with the aim of kind of down selecting as we go forward. And we also have a sort of research direction in what I would call future quantum networks. So this is a bit more speculative, let's say, and I've chosen as a picture here, a picture of the Spooky 1 satellite from Singapore Center for Quantum Technologies. This picture was taken by a guy on the space station. So the picture belongs to NASA. And they took this after the satellite was hurled out of the window, let's say, deployed into low Earth orbit. So this is a sort of a research area in which we're going to explore options to increase the range of quantum communication. So clearly we should do something with free space and satellite type QKD approaches. And also sort of other protocols, so going beyond QKD, so looking at, I guess, device-independent quantum key distribution, whether we can make a sort of practical push for that, and whether we can use entanglement swapping for something useful, right? So this is the idea there, right? I guess I wasn't aware of this EPIC question before I got involved in this meeting, so I'm sorry I haven't explicitly answered the EPIC question here, so I'll try and answer that right now. So what do we do? I don't know yet. I have plans, but we don't currently do that much beyond like trying to recruit and trying to get ourselves set up. And what are we looking for? Again, I don't quite know yet, right? But certainly we're interested in developing some kind of robust supply chain. So I guess I've mentioned here, we've got some domestic challenges. This is, for example, we're trying to set up a research center in a place that doesn't really have any prior heritage of doing research, particularly in quantum, right? So that's obviously got its own challenges, but I hope it's also an opportunity because we have this kind of blank state. We can try and establish, good first principles research here. Again, the local industry, we have, of course, there is a local telecommunication industry, but we need to educate them. We need to promote our use cases and try and do some technology transfer into that. I think there's a great opportunity there, particularly because the people in this part of the world are very keen on sort of high-tech technological solutions, and they're very familiar with transformative technology. They've seen that before their eyes, so I think it's a fairly easy sell here to get people excited about new technologies, whereas I get the impression that might not be the case in areas that have much more developed industries, right? We also have a challenge in that our domestic capabilities for fabrication, telecom equipment and stuff, all of that is present here, and maybe this is just my impression. I've only been in this country for about 6 months, but it's not especially well connected, certainly nothing like it is in Europe. So I think we have the opportunity here to try and build a network within this country and try and identify different capabilities and hopefully also niches which we can then work to try and provoke people to fill these niches, right? And then internationally, I think this is common for everyone here, right? We found that sort of a lot of our key components come from a very small number of companies, really, right? And so this means supply chains are quite vulnerable. So sometimes you've incorporated a particular, say, detector technology, and then it's sort of the volume you'd like to purchase it in is no longer possible suddenly. And it's, as a small player and as a research institute, it's often quite difficult to predict which of your kind of supply chain, which of your providers are still going to be providing you in a few years' time, right? And I think this comes from the fact that we're mostly still quite a niche industry, so our volume requirements are quite low. And I guess all of you working in these companies here will know this very well. But it's quite hard to to build a sort of to build kind of a industrial R&D around such a small potential market, right? Or sorry, such a small current market. We hope a large potential market. And I've also mentioned here that export restrictions are starting to become more visible. So perhaps this is something which maybe you guys within Europe don't see so much. But certainly working in Singapore and working in the United Arab Emirates, we've come across a few situations where we are struggling to get particular devices exported to these places because of, shall we say, overly cautious, I would say, export restrictions that are already in place on the number of devices and technologies. So this is something which we need to be careful and try and work around, right? Because I think, as a communications guy, communication is very much about, it's a two-party at least, or at least a multi-party kind of thing. And so if you erect borders and stop people from exporting technologies, then you are fundamentally restricting communication opportunities, and I think that's something which we should be working against, right? So let's see, I can move to my last slide, which is just a finished slide. So thank you very much again for having me. I hope I wasn't too off topic here. And yes, if any of you guys are interested in what we're doing and would like to connect, then please get in touch. I've got my email address here, and I think it's probably somewhere else on the EPIC website and so on. Thanks. Thank you so much, James. If you say the word networking, you are in the right place. If that's what you're looking for, then you're definitely in the right place. So let me see first if there is no questions, then I will start by introducing you to some companies. I don't know if you know, for example, Freedom Photonics, one of the leaders when it comes to integrated photonics. Can you tell us about Freedom Photonics, Steven, sorry.
Sure. Hi, Sonny, can you hear me?
Hi.
Hi.
I can hear you.
Yes. Great. Happy to be here. So yes, Freedom Photonics is a small business in Santa Barbara, California. We develop, as mentioned, sort of photonic integrated circuits in a number of material platforms. covering, typical group 3-5s, like indium phosphide, gallium arsenide. We also deal a lot in group 4 materials like silicon photonics, silicon nitride. And we develop a number of different components ranging from tunable lasers to high power lasers and photodetectors. I do have one slide, I suppose, that I can show, if that's okay.
Yeah, sure.
Okay.
Yeah, we want James to know all about what you do.
Sure, happy to help. So this is just a high-level overview of Freedom Photonics. Again, a number of our capabilities are sort of listed here. We consider ourselves to be somewhat of a vertically integrated company, going all the way from design to fabrication to packaging. And we develop a number of components, both private label and sort of commercially off the shelf that are available. Some of them are shown here at the bottom, but as I mentioned, tunable lasers that cover a number of optical bands, high power lasers and narrow line width lasers, upwards of hundreds of milliwatts and hundreds of kilowatts, hundreds of kilohertz line width, in addition to other photodetector components, and the ability to kind of put all these components together in a singular package. And I think to answer, the typical EPIC question. So again, we can provide these services to the community. We do this for a number of different companies who come to us for challenging problems. We like working on the most difficult problems in photonics. And what can you do for us? We're looking for opportunities to help. That is what we want to do, is to provide the most advanced devices for the community. And we also, as I mentioned, work in a lot of different platforms. So we're always surveying what is out there. And so if you have a platform you think that could be useful for us to utilize, we're happy to discuss. We work with a lot of partners, both in the US and in Europe. And for more information, my email is here below.
You can always exchange contacts also in the chat. Thank you so much. And let me see, because I think we have a question from NKT Photonics. Yeah.
Hi.
Hi.
Thanks for having me. This was a question for James. Very happy to see the UAE stepping into the quantum field. I think I saw quantum computing on your list of activities. Could you perhaps elaborate a little bit about your approach or maybe some of the activities you have in quantum computing?
Sure, absolutely. Of course, with the caveat that I'm not the quantum computing guy, so I'm a communications guy, but of course I hang out with the guy all the time, so I can tell you a bit about what they're up to. So the quantum computing lab here has a, let me see, I'm not sure what the right term is here, but they have some kind of formal agreement and partnership with Kilimanjaro, which I think is public knowledge. I think I can talk about this. And so they are working on similar technologies, right? So complementary technologies, let's say. So it will be superconducting qubits, the sort of flux transponding qubits, inside sort of superconducting cavities. And this is the approach that will be taken here. I think the goal of the lab here is to basically try out new things, right? So they're going to attempt to explore new ways to make these qubits and to interface them and so on. So this is the kind of the goal they have, right? But it is definitely superconducting qubits as the fundamental technology. So it's not photonic qubits or anything like that. If anything, that would be my problem, right? So yes.
Thank you very much.
Thank you. I think I saw also a question from Thomas from Fraunhofer ISIT. Thomas?
Yes, sorry, that was just by chance. No question, sorry.
Okay, no problem. Okay, let's see what Jose thinks about this.
Well, first of all, James, I'm very sorry that I said Israel. I don't know what was in my mind. This Friday, I really can't wait for the weekend. But I want to go back to NKT, because I'm a huge fan of supercontinuum lasers. I'm a huge fan of that. I really want to understand what applications do you see in supercontinuum lasers. You are managing to go to actually very long wavelengths, meeting a broad wavelength range. What opportunities are you seeing in the quantum market? And most important, give me some work. What companies can I introduce you? Ask her, unmute yourself, because otherwise we cannot hear you. We really want.
All right.
Supercontinuum lasers in quantum, what applications?
Right. So yeah, we're probably most known for our supercontinuum lasers in the at least in the scientific community. We've seen over the couple of years. Well, maybe just introduce supercontinuum laser is a type of fiber laser that outputs a spectrum that covers the entire visible and the near-infrared range up to about 2500. That has been extensively used in spectroscopy and addressing, say, NV sensors in diamond and that kind of research within quantum optics. But perhaps less known is our DFB type of laser. We have a whole plethora of lasers, including picosecond lasers, which was, I think, up before. Go and check those out. In the narrow line with laser field, which is probably our main type of laser in quantum these days. The concept is we have these DFB lasers that are typically operating in the infrared band, but most of the ion trapping and neutral atom trapping takes place in the visible. So what we've done in the very recent years is we've taken these very low noise laser platforms and converted them into visible lasers. So we today can address most of the most used atoms and ions in the visible band with DFB fiber lasers. And we're talking lasers with line widths in the hertz range and very high powers. So that is probably more appropriate than a supercontinuum laser.
Single frequency lasers for ion trapping has been a business being developed already, and I think M Square has done a great job as well there. Thomas, very good job there. So could you reveal, if it's possible to us, with whom are you working on ion trapping, and maybe we can find you similar companies for you to interact with?
Right. So
I've seen many of your lasers.
Right, so let's do the epic questions, right? Yeah. So right today, we are looking for well, of course, customers, but also partners and employees to get this off the ground. We are mostly partnered up with your typical university groups, but also can't talk much about that. But a lot of quantum computing companies that are targeting quantum computers based on either strontium, barium, or ytterbium. So anyone who can supply anything downstream from the laser in terms of quantum computing or optical clocks are someone we would be interested in getting in touch with.
Thank you very much, Asker. And I really am a huge fan of what you're doing in fiber sensing and also in the supercontinuum generation. The Mid-Infrared Alliance is coming, and you are one of the drivers of that. Thank you very much, Asker. I believe that it is time now to get serious. We have 2 more presentations to go, and the next one is one that I've been really wanting myself to introduce. We want to cooperate with Huawei. Huawei is setting up lots of R&D activities in Europe, and in quantum technologies is huge room for cooperation. I have the honor and pleasure to introduce Markus Brunner, who is the chief expert for standardization on Huawei, who's going to talk to us about quantum technologies, most important, about how we can help him on quantum activities. The floor and the attention of everyone goes to the red. Huawei goes to you.
Thank you very much, Jose. Thanks everybody for being here. Hi Don, not seen you for quite some time. Yes, I'm really coming from the quantum communication side of the company. So I'm not going to talk about the components we need from a communication system level perspective, but I'm going to show you a bit on how our thinking goes towards the future communication area, what is needed, what our views are on that you can adapt your components and technologies which eventually fit to that. And as Jose was saying, I mean, we are here as, at least my department is here as an end user of those technologies, and we don't have no intention to develop them. So that's why I'm here to talk about this. I don't think I need to go too much into detail on Huawei. Just to say again, I mean, on the research side, there are several areas of research and different timeframes, and we can target all of them for any type of cooperation we can target all three areas, from new discoveries to technology invention to product innovations. However, our focus on Huawei research is not the product part. And I'm sort of in the middle of it. So in the standardization activities towards ecosystem development and product shaping, things like that. Huawei is a large company. There are a lot of other areas. There are a lot of other also people in Huawei working on photonics-oriented work. So I know these people, but not everybody can present here at EPIC. So we believe actually sort of the age of light is now. Just brought a bit of a few figures from the commercial side. That there is the expectation that photonics, quantum-oriented technologies are going to have quite a bit of a boost in the future years. We also believe there will be more and more jobs being created through quantum and photonic technologies. And naturally, we hope as a telecom system provider that has an effect on our business as well. There are really a whole lot of different technologies needed for the different applications. And I've just listed here a whole lot of different applications people foresee to have there. And this is sort of like the time frame to 2025. If you go further out, people have even more crazy ideas. And depending on what products we talk about, that probably we need to even think beyond that. But this type of areas is what we feel is of interest to the optical communication and quantum communication part. As Huawei, we basically started just recently to talk about a vision which we call F5G. F stands for fixed. It's not the mobile version, but it's the fixed version, the fifth generation of fixed networks. And that's from core networks, the high speed, long distance core, up to access networks, up to home networks. That's what we have today. And the vision is that we're going to go much more fiber. We go full fiber connectivity, even further out in the network. The picture shows you here that we go with optical communication, not only to central offices, but much more also to sites, depending on the deployment model at the moment, to sites of mobile communication, to enterprise sites, and so on. We go from fiber to the home to fiber to the room. If you come with high-speed connectivity to your home, it's these days hardly possible to distribute that high-speed communication within your home. So we need to go further out into the room. On the enterprise side, probably you go from a fiber to the enterprise to fiber to the desk. And then we also look into applications in the factory or vertical industries where you might go with fiber to the machine. So this all this type of fiber and going out with the fiber naturally is also asking for security topics, and there QKD type of applications might be very useful. So far, they are mostly applied in the more long distance, high-end part. But if we want to grow out into the fine granular distribution of communication, we also need to have versions of that in a like lower price range, probably not as high speed as we have it in the core. So that was sort of the vision of the F5G, and you see that here in the middle of that. So we are coming from the fixed 4G, which is sort of the traditional fiber to the home, which is normal video, TV, gaming type of applications. Now, if you go F5G, fiber to everywhere, there is more virtual reality gaming, passive optical local area networks, wireless backhauls, mid-hauls, front hauls, 3D shopping. Not sure whether you guys have seen that. There's first companies allowing to show yourself with the new glasses virtually, things like that. in the industry, there is more and more virtual reality needed in industrial settings as well. So this is sort of the age of where fiber goes everywhere. That fiber is naturally optical, but we believe beyond F5G, we go one step further. We might be able to get rid of fiber. So we might want to use light-based communication without fiber in the free spaces. We feel that there is much more different applications than pure communication and bringing the internet to your home and to your devices. So all types of sensing-oriented application are benefiting from photonics technologies as well. And then, since apparently it's more, or it's better to talk about quantum communication than on photonics, but we believe that quantum communication is trying to get rid more and more of the electronics. So the PICs, what we know today, is a very interesting bridge technology going from electronic only type of equipment to mixed equipment, and eventually we believe it will go to quantum only type of equipment. And here I'm talking more about the communication part that we heard talks already on the quantum computing side as well. So this is the vision, and the applications can be, I mean, it's sort of always difficult to talk about future application, from holography, brain-computer interfaces, remote surgery. We have here as just sort of like a few examples, and I'm aware many people have talked about those examples already as well. So what can EPIC do for us? We are looking for collaboration on all levels, and I basically showing here the different levels. On the left side, more on the fundamental technology research, we are naturally very interested in collaboration in a peer-to-peer manner. But then we are also if it comes more to the applied technology research, we are very interested to join projects in the European frameworks, like under the Photonics Europe or the SNS joint undertaking type of programs, willing to do that. On the standardization side, this fixed 5G, F5G topic, we are currently running an organization within ETSI, the European Telecom Standards Institute. We were just participating in an ITU workshop on quantum communication and what standardization needs are available, which has been held together with IEC. So we are looking at quantum communication also from the standardization perspective. And then naturally the industry platforms like the EPIC on the more commercial level, we are naturally very interested to hear new use cases we can bring in our technologies, but we're also very interested to understand the technological developments and how we can use that in our systems. So the bottom line is we are looking at deep cooperation based on the areas of interest. I can only talk here about the optical and quantum communication part of the industry. And if you want to contact me on other areas, I can get you in contact within Huawei Europe with different people in different locations. If you're interested more in the standardization aspects, the ETSI ISGF 5G is naturally very interested in looking into this new areas, new developments in the optical communication area. What needs to be done? What are the new use cases, new applications coming along? And what are the requirements then for the communication technology we would need to develop?
Thank you so much, Marcus. You made the perfect introduction, because now is for me the most exciting part of the meeting. The part of quantum that makes me the most exciting is QKD. I think I can't hide that. I want to have a nice round of companies that eventually I'm going to introduce to you, Marcus, for a cooperation. And I'm going to start with a company developing QKD all the way from Italy. We have Tommaso Occhipinti. This is the EPIC company on QKD solutions. Tommaso, you are developing QKD solutions. Tell us, most important, how the EPIC members can help you. The EPIC question.
Thank you, Jose. Just to briefly introduce myself, I'm the CEO of the company that is based in Italy. It's called QTI, and we produce complete plug-and-play QKD systems for telecom applications. So it's also very nice to speak just after Huawei. It's really a good thing. Thank you very much, EPIC, for this great opportunity. So we provide technologies, equipments for telecom operators. And our future vision is something very related to something that I listened some minutes ago. So the fact to go to the home with QKD. So this is something that it's really, really interesting for us. So this is our future, let's say, objective. So regarding that, we are looking for collaboration to enable that and to develop something, for example, with the photonic integrated circuits. We are already working on that, but any kind of collaboration regarding that, it's really, really important.
The challenge is late, and I'm going to cover it. I'm going to go to a company that I really love. This company is called Chi3 Photonics. Johan Giesz is with us and is very active in QKD, looking for test beds cooperation, which is something that QTI can help you with. And we're also in contact with most test beds. Johan Giesz from Chi3, welcome to the show. Answer the EPIC question.
Thank you, Jose. Thank you for the introduction. Yeah, very nice presentation that we have here. Very nice people. I was actually talking with the people from QTI this morning, so we are already trying to set collaboration. And basically, what we are doing is Untitled Photon Source, and we are trying to implement our sources in QKD networks for multiplexing applications. So we are looking for local networks, to create local networks with QKD. And we are basically looking for some test beds QKD lines in order to implement our system. So that's why I'm here today. And I would be happy to connect with everybody who's happy to do something like this.
Johan, if you don't know Marcus, this is one of the two companies that the two of you need to talk, because you have something that they are really looking for. But Marcus, that's not all. I'm going to try this. Let's see how it works. I'm going to go all the way to Wuhan. I've been going to Wuhan for many years, and I always have to tell my mother where Wuhan is. I don't need anymore. I'm going to go to Wuhan because the NOEIC is represented in the room. GQ, can you hear us?
Okay, I can hear you.
Yes, tell us what you do in QKD, and most important, how the EPIC members can help you.
Yes, so currently our company is developing silicon photonics modulator for discrete variable QKD. And we also have all the necessary components for continuous variable QKD. But as I know, the 3-5 based materials is also very important to QKD, like the laser and the indium phosphide, indium gallium arsenide, single-photon detector for QKD. So actually, we are getting all the necessary components for QKD, except for some magneto materials. You sometimes need to implement the isolator in the QKD. So currently, we cannot integrate such component on the chip.
So you're looking for a partner who can provide you with magneto materials that are suitable for a very, very important, interesting R&D project on bringing magneto materials to silicon photonics.
We hope so, but as you know, the typical QKD products look like a pluggable blade. So we can put some integrated photonic circuit on the blade with some discrete component like an isolator. It is a very practical solution to the product.
GQ, thank you so much, CSEM, for being with us today. We are looking to introduce you to many of our members. It's great to be global today. And finally, I want to close this Q&A to go to one of the companies, silicon nitride and MEMS combined, one of the companies that is making a success story out of this, Aeponics. Francois Menard, we are talking about QKD because we want all of us to help Tommaso as the system integrator to help Marcus as the end user. What do you do in QKD?
Well, as you know, or as people have come to know, we are working on PON, and one topic is how to overlay QKD over PON infrastructure. So I had a question for the presenter on fixed 5G because it still isn't clear in my mind what is the actual contribution of ETSI as a standards body towards doing stuff that would otherwise be standardized in the physical layer of the PON, which is usually done in ITU Q2. And the question that I have is, which standard body is going to tackle how to overlay QKD over the ideal physical layer for connecting multiple people to a fiber optic network, which is PON?
Yeah, thank you, Franz. Probably I just take that as a question. Yes, F5G is sort of like the more umbrella-oriented organization where the use cases, architecture level work is discussed. And now if you talk about QKD, I mean, the first discussion is what type of security you need for PON. And I guess you know that the 50G PON discussion and security just happened this week in ITU Q2. So basically the F5G is sort of like more putting up the requirements, what are the use cases, and the ITU Q2 would specify the details on the wire or in the bits, on the bit level type of things. So that's sort of the difference. And there is a close collaboration between the two organizations anyway.
And I want to finish this. The two of you, Francois, is really nice, Marcus. The two of you need to talk. I think the two of you are already in touch, maybe. But before that, I cannot finish around a Q&A without going to the end user. My favorite end user is Henry White from Biosystems when it comes to quantum. Henry, from the point of view of Biosystems, how do you see QKD? And maybe what kind of room for cooperation in terms of test beds can be here?
Yeah, I mean, the whole QKD technology is really quite exciting the way it's maturing. One of the challenges we see is we'll be looking at applications where we want to see free space systems. So this will be between mobile but fixed links, but also links between moving platforms as well. So one of the things, yeah, we're very interested in seeing how we can make use of this technology. And one of the things I think we might be able to offer to people in the future is platforms and demonstration systems to test some technologies on more challenging environments. So yeah, that's an area of definite interest to us.
Thank you very much, and we were going to make many introductions for that, but now it is time to go to our closing speaker. We go to Ivan Davis, who is the Group Technology Director of IQE. Ivan, thank you so much for being with us today. Send us off the way that we deserve. What a great meeting. The floor and the attention of everyone goes to Cardiff, goes to Wales. Ivan, I don't think we can see your slides yet.
I hope you can see this now.
Yes, let's go slideshow mode.
Yes.
And I think we'll be ready to...
Oh, it's a bit slow. How is that?
It is perfect.
Okay, well, thank you for the introduction, Jose, and good afternoon to you all. I hope to give you a good closing talk this afternoon and introduce... Something's disappeared.
Yes, all is okay. We had a little bit of a problem, but solved.
Technical issue?
Yes, but it's really fully resolved ultra-fast photonics way. Let's go to share your screen again.
Okay, let's go again. Yes. Okay, so IQE, I'm going to give you a very quick introduction because I know we're time constrained today. IQE is right at the bottom of the supply chain. We manufacture materials, semiconductor materials, compound semiconductor materials for use in lots of different photonic and microelectronic applications. But today I'm going to talk to you what we do in quantum. Quick introduction to IQE. We're a global company. We are headquartered in the UK in Cardiff. We have 4 sites in the US, 4 in Europe, and 2 in Asia. But I'm going to concentrate today on the ones in the UK. You see on the bottom left our brand new foundry, mega epi wafer foundry in Newport. You can see some photos of the clean room there. And one of the typical reactors that we use, you can see a 15 by 4 inch reactor there, which grows indium phosphide and gallium arsenide based materials principally. So we've got 24 of these across the 2 sites in Cardiff and Newport, lots of characterization. And then in the bottom right-hand corner, this is relevant to the talk today, that we have a lot of, we've been around for 33 years now, but certainly we're very active in collaborative R&D. And we're going to show you quite a number of examples of that. But before we go there, we principally manufacture high volume epitaxy, 300,000 6-inch gallium arsenide wafers a year and over 100,000 indium phosphide wafers, and a long history in VCSELs and indium phosphide lasers. So I want to give you a quick update on where the United Kingdom quantum landscape, and I know David on at Kelvin Nanotechnology would have mentioned a few programs involved in this big program. So roughly 6 or 7 years ago, the United Kingdom Research and Innovation invested £1 billion over a 10-year investment in 4 key technology areas. We've talked about a few of them today: quantum computing, secure communication, sensing and timing, and imaging. And you can see the map of the UK here. They were set up with 4 hubs in Glasgow, York, Birmingham, and Oxford universities, linking a lot of other universities. And then over the last few years, quite a number of programs have been managed by the UK's innovation agency, Innovate UK, where 153 million of government support towards the commercialization of quantum technology has been awarded, and targeting transformative change across a number of the sectors that you can see. And we've discussed a lot of these in the talk this afternoon. So I'm going to give you one example, and I know Jose loves this topic. So this is a typical QKD project, which has been going roughly about 2.5 years now. And IQE is there on the very left-hand side as one of the component developers. So we manufacture single-photon detector and single-photon emitter compound semiconductor materials. We do a lot of collaboration with UK universities. Toshiba is the leader of the project, involved in systems. We have cryptography, National Physical Laboratory, you've heard of already today, and quite a lot of end users, very, very diverse end users, BP, for example, and then system integrators in the form of British Telecom as an example. Now, one of the 2 of the things that have partly emerged, at least from this project, you will see that last October, BT and Toshiba announced the first deployment of a quantum secure network. Now, this is round the corner from Henry White in Bristol, and this isn't free space, Henry. This is optic, but needless to say, IQE is actually working in some free space QKD programs as well. This one is an ongoing test bed, if you like, within the consortium. And also last October, Toshiba did launch a business in the UK selling quantum key distribution systems that you can see on the bottom right there. So this is a key project for us. It's coming to a close very shortly, but I'll say a little bit more about this one in a few slides' time. Associated with this project, though, is the contribution of Toshiba, which I've just mentioned. We are working with them on indium phosphide-based single-photon detectors and emitters, quantum emitters on the left-hand side of the slide, involving the first single-photon entangled LEDs, and working more recently on edge-emitting LEDs, and quantum detectors in the form of SPADs, for QKD applications, and then quantum networks. And I've obviously mentioned one such example of a network that's currently being trialed in Bristol. So a lot of aspects of design and advanced characterization of state-of-the-art quantum devices with the first entangled LEDs and ELEDs, and now also gigahertz single photon detectors. In addition to indium phosphide single photon detectors and emitters, we're also involved in programs on VCSELs. IQE's been manufacturing quite a lot of VCSELs for the mass market in the form of 3D sensing in recent years. You can see in some of the consortia within this big quantum technologies program in the UK, we have 5 6-inch wafers manufactured by IQE, which have been fabricated at the Institute for Competent Semiconductors at Cardiff University. And a lot of the applications for VCSELs in this big quantum technology program are targeting atomic clocks. We got on the left-hand side of the slide, we can see an application for cesium atomic clocks, where we have a lot of laser design and simulation ongoing at Cardiff University and ICS Limited in the consortium. Of course, high uniformity epitaxial layers at our joint venture with Cardiff University, which is the Compound Semiconductor Center, CSE, with very tight wavelength tolerances, polarization in sensitive single mode VCSEL performance, and novel characterization processes being developed at the National Physical Laboratory, NPL, where there is now a National Quantum Metrology Institute. And on the right-hand side, VCSELs towards developing magnetometers, a program called MAGV, where VCSELs target 852 nanometers of cesium transition and 780 nanometers for a rubidium transition. Applications for those, you can see typical ones at the bottom of the slide in preventive maintenance and manufacturing process control and object detection underground. Now I'm going to come to my last slide, which I'm going to combine with the archetypal epic question. So what are we going to do from to follow on from some of these big projects that we've been involved with? Well, we decided that we needed to move a lot of vertical projects within this quantum technology program and start to put together a program which would address a lot of the challenges, addressing barriers to the adoption of quantum systems and challenges involved in manufacturing, so in upscaling component manufacture. And this is a new program running for a few months now called QFoundry. And we are saying it's the UK National Foundry for Quantum Components. Now in components, I'm saying epi wafers, device fabrication and packaging, characterization and testing, and of course design. And this is bringing together the UK's most established supply chains to address these critical challenges in manufacturing for the world's first, we believe, quantum photonic component foundry. So we'll be working principally on, again, the single mode high stability VCSELs, and of course, further enhancing the technology platforms for single photon emitters and detectors. And you can see all the partners there coming from quite a number of the already existing vertical programs with demonstrators, targeting markets in quantum key distribution, in LIDAR, medium wave infrared sensing, atomic clocks, and quantum magnetometers. So what can we do for you? Well, we can provide a capability, or we're starting to look into providing a capability for ultimately what will be an open access foundry. That's the target. And what can you do for us? Well, if you'd like to give us, we of course can manufacture epi wafers alone, but also in the form of the supply chain through up to packaged components. So what you can do for us is to engage with us and tell us what you want, give us your designs. We have typical business models that IQE has had in its 33 years of existence as a pure play epi wafer manufacturer. We'd be glad for you to engage with us.
Thank you so much, Ivan. I can't wait to travel again to see again what you are setting up in Cardiff. How many new reactors you are buying for this pixel boom that you took for markets like 3D recognition. Congratulations on that. Pixels are manufactured in Europe for most of the high volume applications you can imagine, thanks to IQE. Thank you very much, Ivan. It is the most beautiful time of the meeting, which is the closing remarks, so we can start the weekend the way that we deserve. I want to go to two people to give me a closing remark. First on the academic side and then in the end user side. On the academic side, I want to go to James. James, you joined this meeting for the first time all the way from Abu Dhabi, looking for partnerships. What's the highlight in your mind? What kind of cooperations can we start after this?
Sure, thank you. So again, thank you very much for including me in this. It's been really interesting. I think I've taken away from this already. I need to contact all the foundries again. I've been meaning to do this. I've already contacted a few of them, so it's been great to see. So particularly, I was very interested to see the lithium niobate foundry coming on. That's interesting. And of course, the silicon nitride activities that are already going on are pretty exciting as well. I guess what I haven't heard from is anyone, it's been mentioned a couple times, but I'm wondering if anyone is working on avalanche photodiodes, but particularly ones that are based on sort of 3-5 materials and can be used to detect infrared photons. That's something which I mean, I know a lot of, obviously a lot of people are making these things because they must be going into all these fiber-based QKD networks and so on. But if you look around the kind of commercially available landscape, there's not a whole lot of options here. And I guess in particular, so I have got some experience with buying these things from many of the companies that do sell them as sort of final integrated products. And in particular, I think the sort of the noise, the dark counts and so on in the kind of in-gas based detectors are often, let me say, too high to use them in continuous operation mode. So I'm kind of interested in networks that are not pulsed, they're not clocked, there's no system clock. Everything's just happening randomly, right? At the sort of Poisson distributed time intervals. And for this kind of thing, you really do need like very quiet single photon detectors. So I'm interested if anyone's working on those for telecom light. But of course, if you want quiet detectors, it's better, you could simply say, well, hey, go superconducting. And that's great. I have superconducting detectors, they're wonderful. So if anyone's working on superconducting detectors that are really focused on sort of deployment, right? Like I want superconducting detectors that don't require massive lab infrastructure to run, right? Even a small cryostat is a bit of a sell if you're trying to get this thing stuffed into someone's MDF room, right? So I'm very interested if anyone's working on this kind of technology.
Getting rid of the cryo is very difficult, but in a separate email, I will introduce you to, for the SPADs, to companies like Caleste, who is developing something fantastic, and for the SNSPD, I will introduce you to Single Quantum, but it comes with a little bit of a cryo. It comes with a little bit of a cryo, something like this.
I have to confess, I'm already a Single Quantum customer. So
oh, fantastic. Well, yes, and I want to go to the final closing remark, the final of all. This meeting has to end up with the highlights of Henry White from Biosystems. After these 2 hours, Henry, what's on your mind?
Yeah, well, once again, thanks for a great event, Jose. You chair it really well again, and some really interesting presentations there. And needless to say, a number of connections been being made in the background while all this has been going on as well, which is always good to see. So yeah, working with a number of the partners on the presentation already, and hopefully with ones in the future. I think a couple of points. I can see there's the way things are moving. We need to move a bit better to make access to some of our test platforms for people to try out technologies on. So do feel if people feel they're getting to that level on more challenging platforms, do get in contact. And I think picking up a point that James made earlier about we're really interested in robust supply chains, and so export control on technology is really concern in some of these areas. So just yeah, anything anybody can do to help with that, but no, really interesting technologies being talked about.
Thank you so much, Henry, for this. It is, of course, 12 minutes out of time. I have to apologize for that. Season 1 is over. No time to cry, because we need to start preparing for Season 2. And we're already scouting companies in atomic clocks and network synchronization, ion traps, gravitometers, and other quantum sensors, and large-scale qubit generation using photonics. If you are active in any of those topics, contact me, jose.pozo@tepics.com as soon as possible, because we want to get in touch with you. We really want to continue our quantum activity. this meeting is over, and now it's sunny in Noordwijk, so we can all go and relax a little bit outside. But remember that the most important part of the meeting is the follow-up. Today, we found out many business opportunities. Make sure that you get in touch with them. If you want to get in touch with any of the participants, drop me an email, a short one, please, jose.pozo@epicdataScience.com, and I will make sure that I introduce you to all the different members that were in the meeting today. Also, remember that at epicdataScience.com, we also have the list of upcoming events, and on Monday, with really top speakers, we have a meeting on photonic integrated circuit packaging, and it's going to be really awesome. But before that, we have 2 days to relax. My name is Jose Pozo. I love photonics, and I love you even more. And I'm talking on behalf of a fantastic group of people who dedicate their life to the photonic industry. People in the laser sector, medical sector, integrated photonic sector, quantum. We have a great innovation partner. We have a great group of marketing experts. We have a CFO. I think we all know our CEO, Carlos Lee. Be epic. Wear a mask, wash your hands, and get vaccinated, even if it is with AstraZeneca, because I can't wait to start traveling again. See you soon. Bye-bye.
Thank you so much, everybody. See you.